Here's integrated 3. It's problem 1-42. It says, create a table and graph for the function g of x equals 2 over x, then completely describe the graph. So, to start out, I'll go ahead and make a table. We talked about these rational functions in class, but I know that they're brand new to you, and this one looks a little different than the ones that we did in class. So when I make my table, I like making mine this way. And I'm going to start out with some negative numbers and get up to some positive numbers and just see what happens. And then I might put some numbers in between them. I'm going to start out with, like, I'll go -2, -1, 0, 1, 2, and I'll see what happens. And then later after that I might add some more numbers to my list. So if I plug in -2 down here, it's 2 over -2. That gives me -1. If I plug in -1, 2 divided by -1 is -2. If I plug in a 0, I'm not allowed to divide by 0, so that's undefined. If I plug in a 1, I get 2. If I plug in a 2, I get 1. Let's see what it looks like so far, and then we'll decide. I think I'll do it in pencil. So if you guys remember that day in class that we did some of these, I think we had 1 over x minus h. And everybody had a different h, and everybody had these graphs with these asymptotes. And one group, I remember, did a graph. It was just 1 over x minus 0. So their asymptote was actually on the y-axis. So we draw a dotted line to show that it's an asymptote. And then when I plot points, I'm not going to just go boom, boom, like that. Okay, I want my points to actually be on my graph. So, like if they're graphable, like -2, -1, it's graphable. I don't want you guys to just do a sketch, because this one, they asked for a complete graph. That means, and you went ahead and plotted points. Those points better be on your graph, or you're not going to get credit for it. And you can, and if it helps you, you can check them off, like, oh, I already graphed that point. I just need, not every single point has to be on it, but I need the points that are good, that can land on your graph. I really want them on your graph. Okay, so -1, -2. It's right there. That's my asymptote. 1, 2, and 2, 1. Now, I do know that it's going to go like this and like this. I know that because of all the graphs that we did together in class. I think when we were in class, we were trying to get numbers that were even closer and closer. But if you answered your homework question and it looked like this, that's okay. And then it asks you some questions. It says that we have to completely describe the graph. So I remember, maybe it was the first or second day of class, we had to make some graphs, and we completely described them. And so I went back to the page in our book where they first asked us to completely describe things. And so I want to answer some of these questions, like the shape. I'm going to say something about a line of symmetry. I'm going to say there's symmetry about the origin. So when I'm describing my graph, I'm going to look at all the things that they want me to talk about, but sometimes they don't really apply. Like this one opens, like opening upward and downward, that's something we would talk about for a parabola. There's an asymptote. that, what is this dotted line? What's the equation of it? I guess it would be x equals 0. Okay, and then increasing or decreasing, well, it's kind of doing both. I'm not going to really use that. X and Y intercepts, there aren't any. Domain and range. I'm going to say the domain and range for sure. So domain, what is the domain? Well, domain is the x values. So it goes off to the left, infinitely to the left. So, and it goes infinitely to the right, but you can't plug 0 in. So I think what I'm going to say is all real numbers except 0. Or in other words, x cannot equal 0. And then the range, I think I'm going to have something similar. It's going to be, because it goes infinitely high and infinitely low. So I'm going to say it's all the real numbers except for y can't be 0. Endpoints, there's no endpoints. Max, it's continuous. And that's all I'm going to say about it. So I'm trying to make a point that when you sketch a graph, you want the points on your table to be on your graph or at least look like they're on your graph. Like, for instance, I didn't plot 3 comma, well, what would 3 be? 3 would be, if I go 2 over 3, that would be 3 comma 2/3. Graph it on my graph. But doesn't that look like it goes through 2/3? Like, you need your lines of your graph to look as though they're describing the data that's in your table. Okay? And that's it.